Hello, everyone. Today, we will learn Chapter 7, Ethereum Blockchain. This chapter mainly includes the overview of Ethereum and its core concepts and principles. First, let's start with Section 1, Overview of Ethereum. The origin of Ethereum mainly results from the limitations of Bitcoin's scripting language. While Bitcoin scripting language can support a variety of computations, it cannot support all types of computations. For example, its lack of loop control, value blindness, and the non-divisibility of UTXO make it impossible to be the withdrawal limit of its user's account, and can't provide fine-grained control. Additionally, Bitcoin has other issues like lack of state management and blockchain blindness. This is where Ethereum comes in. Ethereum is a new generation platform for smart contracts and decentralized applications. The development of Ethereum can be traced back to December 2013, when Vitalik Buterin, born in 1994, first described Ethereum and released the Ethereum White Paper. The White Paper detailed the technical design, fundamental principles, and structure of smart contracts on the Ethereum protocol. Meanwhile, he also collaborated with two partners to promote this project. So, in March 2014, Ethereum launched its third version of its test network and eventually moved its headquarters to Zug, Switzerland. Ethereum aims to seek integration and improvement based on the concepts of scripts, alternative coin, and on-chain metaprotocols, enabling developers to create any consensus-based, scalable, standardized, feature-complete, easy-to-develop, and collaborative applications. By establishing an ultimate abstract fundamental layer with a blockchain that includes a Turing-complete programming language, Ethereum allows everyone to create contracts and decentralized applications. People can establish customized ownership rules, transaction methods, and state transition functions. Therefore, Ethereum smart contracts, due to Turing completeness, blockchain characteristics, and the additional power of multiple states, are much more powerful than the smart contracts Bitcoin's scripting language can offer. Let's look at the differences between Bitcoin and Ethereum. Both are global and their properties are public. In terms of privacy, it can be fully transparent while still keeping anonymity. However, there is a major difference between them in terms of smart contracts. Bitcoin smart contracts are script-based and less powerful, while Ethereum is Turing-complete, with Solidity as its representative, making it more powerful. In terms of consistency, Bitcoin mainly uses the POW, proof of work, algorithm, whereas Ethereum supports both POW and POS, proof of stake. Bitcoin produces a block approximately every 10 minutes, while Ethereum is much faster, with a block being generated roughly every 12 to 20 seconds. Thus, we can understand that Ethereum is essentially a combination of blockchain and smart contracts, functioning as a transaction-based state machine. Follow the sandwich model. The underlying protocol should be as simple as possible. The interface design should be easy to understand, and the inevitable complexity should be placed in the middle layer. At the same time, Ethereum adheres to the principles of freedom, immutability, and featurelessness, and no-risk aversion mechanisms. Ethereum architecture can be divided into upper and lower layers. The upper layer includes decentralized applications, browser wallets, mobile wallets, desktop wallets, smart contract development tools, command line consoles, and JS frameworks. The lower layer includes smart contracts, account management, cryptographic modules, blockchain management, and other modules. In Ethereum technology, we mainly focus on the framework shown in the right picture. There are two important components: Swarm, distributed storage, and P2P file sharing system, which is used to store the data required by Ethereum applications and smart contracts. Ethereum's BitTorrent stores each piece of content in a P2P network and addresses it through its hash value. The other component is Whisper, distributed communication, which uses DHT combined with P2P to achieve communication protocols between Ethereum's distributed application nodes. The protocol can send information to a specific node or to multiple nodes using tags or topics in the information. This is the structure of an Ethereum block header. The structure of the block header contains the following parts: parent block hash, miner address, log filter, difficulty value, block number, maximum gas value, transaction gas consumption, timestamp, additional data, mix hash and random numbers, etc. Of course, it also includes the three most important trees: the state tree, the transaction tree, and the receipt tree. Therefore, Ethereum's block header does not consist of a single Merkle tree, but rather three trees separately designed for three different objects. First, the transaction tree represents the transactions in the block. The receipt tree represents the receipts generated by the transactions. And the state tree represents the account states affected by the transactions. Through this series of operations, Ethereum allows light clients to easily conduct and verify the following queries, such as, is this transaction included in the specific block? Tell me all event instances sent from this address in the last 30 days. How much is the balance of my account? Does this account exist? What would be the output if I run this transaction on this contract? Etc. Okay, everyone, that's the end of section 1 of chapter 7.